The MATLAB simulation code allows us to determine the time constant of both resistors. This is capable because it is known that one time constant is 0.63 of the total value. So for the 10 kilo ohm resistor, it is 0.1 seconds, and for the 100 kilo ohm resistor, it is 1 second for the time constant. So here I have my Arduino code. At the top, I define a few different variables that are needed, such as a couple timers, a string to supply the voltage, and an int state for whether or not the Arduino is transmitting a voltage. In the void setup, I start the serial monitor, as well as define my pins as inputs and outputs respectively. I also define my tau, which was gotten from the MATLAB code. This can be changed for either the 10 or 100K resistor. Then within my and then I start my timer as well. For the void loop, I use the same time loop constant principle that was used in the Blink lab in lab 2. I either turn on or off the voltage depending upon whether or not this condition is met. I then down here write the statement that is given. Below here, I take both of the analog reads twice in order to prevent noise, and then I output that to the serial monitor so it can be read by the processing code. For my processing code, I made the necessary changes, such as the 115200 for the serial monitor. Down here, I define all of my lines that are needed for defining the y-axis. Here, I establish the color of my font as well as the font size for the axis labels. I then go immediately on to defining a new size in order to create my legend, and then I have text for those points. And then here I have my ellipses as well as the fill colors for the respective labels. Here I have my circuit. It's just a resistor that feeds from the analog output pin that also has a analog read pin set to it. The resistor feeds to the point where the capacitor line is read. The capacitor then feeds to the ground. Here I have my processing code running at 10 kilo ohms. As you can see, it has a much steeper curve than the 100 kilo ohm resistor that you will be seeing in a moment. Here I have the 100 kilo ohm resistor running. Not only does it have a much shallower curve when compared to the 10 kilo ohm resistor, but it also moves significantly slower due to it having a much higher time constant. The only thing I had to change in order to make this code work was change the tau value here in my Arduino code in order to correct it from being 0.1 seconds to a full second. Here I have the MATLAB code for the analysis of my data. Up here I had to set it up to read through the client, as I have to use Citrix. In order to get it to show voltage, I had to divide the incoming values by 100. And then I had to change the axis label to read volts. Over here you can see the analysis, and it is very similar to the collected data. Here I have the MATLAB processing analysis code for the 100 kilo ohm resistor. I had to change the R value at the top as well as the file name that it is searching for, as well. Just like the 10 kilo ohm resistor, this data matches the collected data.